Today let's work on 69 square root of x together. Let's go through the problem description first. And we are given a non-negative integer x. We will need to return the square root of x. Round it down to the nearest integer. The return integer should be non-negative as well, and we cannot use any built-in functions. So for this problem, I think I would like to use a binary search approach, since we will know that for the for example, let's call the result. Let's define a result variable, which is an integer, and we will know that for the result, all the elements before the result, if we squared the square of all the elements before result will be less than x, and we will also know that the square of all the elements after result will be larger than x. For this reason, we can use binary search. Because of this property, we can remove half of the elements every iteration. So let's begin solving this problem. L equal to 0, right equal to x. Actually, right can be equal to x over 2, but I think using r equal to x does not make much difference to the time complexity, so I just use r equal to x. And while L is less than r, mid will be equal to something. And if left is if mid times mid is less than x, at this time we'll update that. Because we are going to find the square root of x, round it down to the nearest integer, we will update L to middle instead of middle plus 1, because at this time we have this condition, and we will know that the value of middle may become the final result, and therefore we cannot exclude the value of middle. Because we are updating L here, I will define the statement for updating mid to be L plus right minus L plus 1 over 2. In this way, we will not end up in an endless loop. Or I can write like this. Else, if mid times mid is larger than x, right will be equal to mid minus 1. That is because of the same reason when we rationalize L here. because we will return the square root of x rounded down to the nearest integer, we will know that we cannot include r because mid times mid is larger than x, and because mid times mid is larger than x, and then we will know that mid here will never be the result that we need. And else mid times mid equal to x, we will just return it. And finally, after we go out of the loop, we will directly return out, and that will be the result. Let's run. The time complexity will be O log n, since every time in the iteration, we remove half of the elements. So the final time complexity will be O log n. And the space complexity will be O1 since we do not use extra space. That's all. Thank you.